Good morning. Today we are going to discuss about the estimation of hardness of water by EDTA method. First, what is meant by EDTA? EDTA means ethylene diamine tetra acetic acid. In this experiment, we are doing 3 titrations. First titration main aim is standardization of EDTA. Second titration is estimation of total hardness. Third titration is estimation of permanent hardness. So we can automatically calculate the amount of temporary hardness present in our water sample. Generally, water is the main sources of all human beings, animals, plants, etc. So the water must be free from all types of impurities. So in this experiment, we can find out the amount of hardness present in your water sample by using EDTA solution. Actually, this EDTA solution is a complex solution because pure EDTA is insoluble in water. So, disodium salt of EDTA is used in this experiment. This is the burette solution for all the 3 titrations. In the first titration, EDTA is filled in the burette. Standard hard water is prepared out into a conical flask. So, 20 ml standard hard water is prepared out. Then we are adding ammonia buffer. Why we are adding ammonia buffer in this experiment means, actually in this experiment only applicable at the pH range 8 to 10. To maintain the pH 8 to 10, we are adding ammonia buffer 5 to 10 ml. Then we are adding EBT indicator. Listen, in the solution turns wine red color. That means that solution contains hardness. So, what are the reasons for hardness means? Dissolved calcium and magnesium salts are available in this water sample. Automatically, it turns to wine red color. So, 20 ml of the standard hard water is prepared out. Then we will add ammonia buffer 5 to 10 drops. Then add EBT indicator. The solution turns wine red color. This wine red color represents the hardness. Then this wine red color complex is titrated against EDTA solution in a burette. Listen, this is our endpoint, steel blue. So wine red color changes into steel blue. This is our endpoint for the titration 1. So what's the reason to turn wine red to steel blue? Because the reason for the wine red color complex is presence of the calcium and the magnesium salts combined with the EBT complex as well as EDTA solutions, to automatically it forms a complex. That complex is calcium magnesium EDTA complex. Then that calcium magnesium EDTA complex is titrated against that solution. Automatically it replaces their position, it turns to steel blue color. This is our first titration endpoint. Our first titration is standardization of EDTA. So abbreviation for the EDTA is ethylene diamine tetra acetic acid. EBT abbreviation is Eriochrome Black T indicator. This is the metal ion indicator. EBT is the metal ion indicator. We know phenolphthalein methyl orange indicator is an example for acid base indicators. This is the metal ion indicators. This titration is complexometric titration because due to the formation of complex. Calcium magnesium EDTA complex. So this is the complexometric titration. Then again we will do the second titration. Our second titration aim is estimation of total hardness. Same method. Burette solution is same, EDTA. listen, in the second titration, burette solution is same EDTA, pipette solution is ordinary tap water, our sample water. Our aim is to find out the amount of total hardness present in our water sample, tap water or our domestic purposes water. We can find out the amount of total hardness. So again same 20 ml of the tap water is pipetted out, then ammonia buffer is added into the same solution, EBT indicator is again added, the solution turns wine red color. That wine red color titrated against EDTA, automatically it turns to steel blue. So in the titration 2 we can find out the total hardness amount. So first titration is always standardization, second titration is estimation of total hardness. Then third titration, same procedure, burette solution is always same for 3 titrations EDTA. Then third titration pipette solution is boiled water sample. What's the purpose of boiling? Due to the boiling process, all the temporary hardness are removed. Half an hour 100 ml water sample is boiled for half an hour. All the temporary hardness are removed. Only permanent hardness is available. So from the boiled water, we can find out the permanent hardness value. Permanent hardness means it cannot be removed by boiling, but it can be removed by some other techniques. That means external conditioning methods, example, zeolite process, lime soda process. So mainly, what is meant by hardness? Hardness means due to the presence of dissolved calcium and magnesium salts, water does not produce lather with soap. That is hardness, that property. Generally, water easily produces lather with soap means it is a soft water. Does not produce lather with soap means hard water. The main reason for hardness is presence of calcium and magnesium salts. 2 types of hardness is available. One is temporary hardness and one is permanent hardness. So sum of temporary plus permanent means we can find out total hardness value. Generally, what are the units of hardness? ppm. ppm means parts per million. This is the major unit for hardness. Another unit equal to ppm means milligram per liter. This is the units for hardness. From this experiment, we can find out in our domestic purpose the water is pure water or hard water. That means soft water or hard water easily find out. But in our life, in our home, we can easily identify, just take a water sample, just lather with soap. That means easily produces lather means in our domestic purposes, water or pure water. In our laboratory purpose, we can easily find out with the help of the EDTA, pure water, soft water or hard water. So third titration aim is boiled water. Same method, 20 ml of the boiled water is pipetted out. Then again add same ammonia buffer, same indicator. Wine red color is formed. That wine red color is titrated against EDTA. It turns to steel blue. So from this experiment, we can find out the amount of total hardness, amount of permanent hardness, amount of temporary hardness present in our water sample.